Well, hello everyone and welcome back to our series of videos on the topic of respiration. Now in the last video we looked at the muscles and the structures involved in breathing. Right? So we looked at how we breathe in, inspiration, and how we breathe out, expiration. And in this video we're going to continue by looking at what is the difference between inspired and expired air and how can we tell, and also what is the stimulus for breathing. Right? So let's get started. So look for this table in your notes. It is a table that compares the composition of inspired air and the composition of expired air. So basically what the air that you breathe in contains versus what the air that you breathe out contains. And you can see that we're comparing inspired air and expired air on several components: oxygen, carbon dioxide, and so on. Now what I would like you to do is to have a read of your textbook. So the specific page is page 211. And also take a look at this graph, this pie chart, that compares the composition of inhaled air to the composition of exhaled air. And I want you to fill up the table. Alright, as you fill up the table, ask yourself these questions: which has a higher percentage of oxygen? Which has a higher percentage of carbon dioxide? Which has a higher temperature? Now you can try this by breathing in and then breathing out on your hand and feel which one has a higher temperature. And you can also test out which has a higher water vapor content. Alright, so pause the video here, take a look at this table, read your textbook, and try for yourself to fill up the table before we move on. Alright, so hopefully you've done that, and what you should arrive at is something like this. So in inspired air, we have about 21% oxygen, but in expired air, about 16.4%, right? Because some of the oxygen has been taken into the body. For carbon dioxide, inspired air is about 0.03%, and in expired air, about 4%. Okay, so that's because some of the carbon dioxide in our body is being removed. The nitrogen remains about the same because no change to nitrogen. Nothing happens, no absorption, and also no release of nitrogen by the body. Water vapor in inspired air depends on where you are. Some places are very humid while others are not. But whatever it is, when you expire, the air usually is quite saturated in water vapor. And you can see this when you kind of breathe out against a cold surface, then you see like condensation on it. That's because the air that you breathe out contains a lot of water vapor. Again, temperature of inspired air depends. But expired air is usually about the body temperature because the air has been warmed up by the inside of your body. And for dust particles, again, depends on the environment you're in. If you're in a very dusty room, there's a lot. Right? And for expired air, usually there's less because your nasal passages, your trachea, your bronchioles have already filtered out most of the dust particles, trapping them in the hairs and getting rid of them. Okay, so this table of comparison, you don't really need to know all these numbers by heart, but you need to have a rough idea. Sometimes they do ask, and sometimes they do ask you to explain. Okay, so here's a very famous experiment which is used to compare the amount of carbon dioxide in inhaled air and exhaled air. So what you see here are two flasks, right? And here is a tube where someone can breathe in and breathe out. Now I want you to imagine, I want you to ask yourself, think about it for a while. In flask A, is it inspired air or expired air that is being bubbled into the flask? And in flask B, is it inspired air or expired air which is being bubbled into the flask? I want you to imagine someone breathing in and out here. When would it result? When he breathes in, which one will there be bubbling? When he breathes out, which one will there be bubbling? Alright, pause for a while, have a think, and then continue. So imagine now that the person breathes in, right? So that there's air coming out this way. He breathes in, right? Air moves this way as well, and air moves this way as well. So in this case, here, right, the liquid will just be drawn up, right, when he breathes in. But in this case, the air will be drawn in, and then some of the air will be drawn out here to replace the air. So there'll be bubbling in flask A. So flask A is testing for the amount of carbon dioxide in inspired air, because there's lime water here that tests for carbon dioxide. Now I want you to imagine now that he breathes out. Okay, so I'm going to change my pen color. Now if he breathes out, then he's blowing air into inside. So now if he blows air here, the air will just be blown downwards. So no effect, no bubbling. If he breathes out here, then the air will move in and it will get bubbled in. So flask B is actually testing expired air. It's testing expired air for carbon dioxide. So after a while, what do you think you observe? What would you expect given that flask A is testing inspired air and flask B is testing expired air? What result would you expect? Well, you'd be right to say that in flask A, where inspired air is being bubbled here, the lime water remains clear. Because the percentage of carbon dioxide in inspired air is very low, only about 0.03% carbon dioxide. However, in flask B, where expired air is being blown and bubbled inside here, there will be a white precipitate formed in the lime water, right? Because there's a higher percentage of carbon dioxide in expired air, about 4%. Okay, so this is a simple experiment. Sometimes they give you the setup and ask you to explain it, or to give you some other setup and ask you to explain what's wrong with the setup. Now we're going to move on to something quite interesting. But before that, I would like you to try something. Hold your breath and see how long you can go. Pause the video, time yourself, how long can you hold your breath, post it in the WhatsApp group. Tell me, how long? Alright, let's see who's the best. Now if you're still alive, let me share with you the world record. The world record for underwater breath holding is a crazy 22 minutes. And you ask me, how in the world does he do that? I can't even hold my breath for more than 2 minutes. I don't know, right? But we can watch the video together and it's pretty fascinating what people can do. So how did you feel when you were holding your breath? You know, eventually you felt this really great urge to breathe, right? It's like you just had to breathe, right? So why did you eventually breathe? And can you suffocate yourself? Try holding your breath as long as you can to try to suffocate yourself to death. Is it even possible? You realize that after some time, your body just automatically breathes. So what is that thing that stimulates us to breathe? What is the stimulus for breathing? What do you think it is? Well, some of you may think something like this, that we are stimulated to breathe. So let's explore the theory. Is it a lack of oxygen that stimulates us to breathe? And let's look at this experiment here, and this graph. Now this graph shows you the number of breaths per minute of a person, and this line in the center shows you the breaths per minute when the person is breathing room air. So room air, if you remember, is about 21% oxygen and 0.03% carbon dioxide. Now, let's look at this line here above it. This line shows you the breaths per minute of the person when he is breathing 92% oxygen and 8% carbon dioxide. What do you notice? Notice that when he breathes in 92% oxygen and 8% carbon dioxide, the number of breaths actually increases. So he is stimulated to breathe more. Does that fit in with this theory? Now, if it is a lack of oxygen that stimulates us to breathe, then if we give this person 92% oxygen instead of 21%, that means you give him even more oxygen, then if this theory was true, he should breathe less, right? Because at 92% oxygen, he doesn't lack oxygen, right? So he should breathe less. However, we notice that he breathes more. So it seems that it is not the lack of oxygen that stimulates us to breathe, because you know, when I give you enough oxygen, he's still breathing more, he's still stimulated to breathe. So what could it be? Could it be that it is the 8% carbon dioxide that is making him breathe more? And so let's take a look at this line at the bottom. it shows you the number of breaths per minute when he breathes in 100% oxygen. And notice what happens. When he's just breathing in pure oxygen, his breathing rate actually decreases below normal. So he's breathing very slowly. He's not stimulated to breathe at all. And that's because this air here contains 0% carbon dioxide. Right? There's no carbon dioxide at all. So experiments like this lead people to conclude that the stimulus for breathing is a high concentration of carbon dioxide. That means as you hold your breath, carbon dioxide builds up in your body, and it is the buildup of carbon dioxide that eventually stimulates your body to breathe. That's why at 8% carbon dioxide, the person breathes a lot more because he's being stimulated by the higher concentration of carbon dioxide. And at 0% carbon dioxide, he breathes less because he's not being stimulated to breathe. So the stimulus for breathing is a high concentration of carbon dioxide. It is not the lack of oxygen, contrary to what people may think. Now, if you're still lost on this experiment, alright, take a look at your textbook, page 213. There's a description there in words. Okay, so you can look at this here. This line again shows you what happens when he was given 8% CO2, and here when he was given 100% oxygen. Now, there's some pretty interesting applications when you realize that carbon dioxide is the stimulus for breathing. Now, the first application has to do with free divers. Now, free divers are divers who hold their breath. They don't use oxygen tanks. They just hold their breath for a long time and they dive as low as they can. For some people, this is a way of living. When my family went to Korea, they saw some people on Jeju who would dive to find seaweed, and there are people in other countries who dive, free diving to find pearls. So an interesting thing is that free divers hyperventilate before diving. Hyperventilate meaning that they breathe very quickly on purpose, like and that helps them to hold their breath for longer. Now, why is that? Now, a similar application has to do with if you've ever seen any of your friends hyperventilating, it's quite scary. Some people hyperventilate. We often say that the first thing to do is to pass them a bag so that they can breathe into a bag. Right? They can breathe into a bag rather than just keep hyperventilating. Why is that? Go and find out. Go and do some research. Go and think about it. And if you think you found the answer, post it on WhatsApp. Now, a little hint to get you started is to think about this. If carbon dioxide is what stimulates us to breathe, then if we can get rid of all the carbon dioxide in our gas exchange system, wouldn't that remove the urge to breathe? Right? So think along that lines. Think along how removing carbon dioxide from our body reduces our urge to breathe, and you'll get there. Alright, and I look forward to seeing your answers. So that's all for this video. I'll catch you in the next one.